All right, for the second example, you can see that we still have a squared term and a regular term, and we're still going to solve by factoring. One thing that people do sometimes that you want to be careful of is they see that there's a sine x on both sides of the equation and try to divide both sides by sine of x. You actually don't want to do this because anytime you're dividing by a variable, you could be getting rid of some potential solutions that you would normally have if you solved by factoring. So rather than dividing both sides by sine of x, what we're going to do is get everything to one side of the equation, just like we did with the last one. So either 0 equals or equals 0. In this case, since I want to keep my squared term positive, I'm going to subtract sine of x from each side. So I'll end up with 0 equals 2 sine squared of x minus sine of x. In this case, when I go to factor, I notice that there's a common factor. So both this term and this term have a sine of x in common. So you're going to start by factoring out a sine of x. And then do the opposite of the distributive property. What do I need to multiply sine of x by to get 2 sine squared of x? Well, I need a 2 and another sine of x. And then what do I need to multiply sine of x by to get negative sine of x? That would be negative 1. Once you get it into the factored form, the next thing we do is use the zero product property. So I take my first factor, which is just sine of x, and set that equal to 0. Then I use the unit circle to figure out where is sine of x equal to 0. Sine of x is the same as the y-coordinate, so it'll be equal to 0 here and here. So I could call this first solution either 0 or 2 pi, doesn't matter, and then this one is going to be pi. Now I need to set my second factor equal to 0, so 2 sine of x minus 1. To simplify, add 1 to both sides, and then divide by 2. So I also need to know where is sine of x 1/2. Sine's the y-coordinate, so it's going to be positive in the first and second quadrant. And if I think about my special right triangles, if I want my y to be 1/2, that's the shorter side of the 30, 60, 90 triangle. So it'll be more of a horizontal 30, 60, 90 rather than a vertical. So this trig equation has 4 distinct solutions plus all of the coterminal angles. So I want to list all of them. So I'll just start in increasing order, start here, and then go in this direction. So the first solution is just 0. The second solution, closer to the x-axis, is pi over 6. Third solution is also a sixth. It's closest to pi, which is 6 pi over 6, but just short of it. So that's going to be 5 pi over 6. And then I also have pi on the left half of the circle here. Last thing I want to do is add 2 pi n to the end of this to show that all of the coterminal angles would also satisfy this equation.